going to take a brief break from what we've been doing in terms of thinking about first and second derivatives, critical points, inflection points, increasing, decreasing, concave up, concave down, how to sketch graphs, all that good stuff. Going to take a brief break and start looking at section 4.5, which looks at applications, introduces and uses applications of L'Hopital's rule. So I've got L'Hopital's rule carefully written out here. L'Hopital's rule is going to be a trick to evaluate trick to evaluate limits that are otherwise difficult for us to evaluate. So what's going on here? If we have a ratio of, if we have a quotient of two functions that we're trying to take the limit of, and when we plug in 0, basically we're getting a 0 over 0 indeterminate form. What this says is that the limit of f over g is equal to the limit of f prime over g prime, assuming that this limit exists. And we also have to take a look at all these conditions. Everything has to be differentiable in order for us to take limits of things. We don't want g prime of x to be 0, because that could be bad. But this is what L'Hopital's rule says. So if we have, in summary, if we have a 0 over 0 indeterminate form, we can take derivatives of both the top and the bottom separately. We're not applying quotient rule, we're taking derivatives separately. And if this limit exists, then this limit is equal to this limit. Furthermore, apart from just having 0 over 0, we also have that if we have a infinity over infinity indeterminate form, we can do the same thing. So we end up with the limit as x goes to a of f of x is infinity, and limit as x goes to a of g of x is also infinity, and infinity over infinity indeterminate form, we can take derivatives of top and bottom separately. Okay, so this is what L'Hopital's rule is. Let's do some examples of it. So, starting off, let's suppose that we have the limit as x goes to 2 of x cubed minus 8 over x to the 4th plus 2x minus 20. Okay, so what's going on here? So if we plug in 2 upstairs, we get 8 minus 8. That's going to be 0. If we plug in 2 downstairs, we get 16 plus 4 minus 20. So we currently have a 0 over 0 indeterminate form. No, I'm not writing that this is equal to 0 over 0. I'm just notating that we have a 0 over 0 indeterminate form. Everything in terms of what are we allowed to do here, everything's differentiable. The numerator and denominator are both 0. So let's go ahead and take the derivatives of the top and the bottom. And the limit is x goes to 2 of 3x squared over, downstairs would be 4x cubed plus 2. And at this point, when we plug in 2, we don't get 0 over 0. We can just apply substitution. So our answer is 3 times 2 squared over 4 times 3 squared plus 2. And so, what do we end up with? Crunch, crunch, crunch. We get 12 for the numerator, and then we get, oops, I made a mistake here. What mistake did I make? We're plugging in 2, not 3. So 4 times 2 squared plus 2, 12 over 34, 6 over 17 is our limit. So there's one example. Let's do another example. Suppose that I ask you for the limit as x goes to pi over 2 of cosine squared x over 1 minus sine x. Okay, once again, what happens when we plug in pi over 2? So cosine squared of pi over 2 is going to be 0 squared. Sine of pi over 2 is 1. So once again, we have a 0 over 0 indeterminate form. So let's take the derivative of both the top and the bottom. So the derivative of cosine squared x, we're going to use, so cosine squared x, that's really cosine of x quantity squared, so we can use the chain rule here. So we get 2 cosine x times the derivative of cosine x is negative sine x. And downstairs we have 0, derivative 1 is 0, minus cosine x. And hooray, we can cancel out factors of cosine x. And so we're just left with the limits x goes to pi over 2 of, we can cross out those minus signs, and it's just 2 sine x. So what's the limit of sine x as x goes to pi over 2? That's 1. So 2 times 1 is 2. So there is our final answer. Okay, so we'll have more things to do in the future. There's more intricate ways to use L'Hopital's rule. But why don't we stop here for the first video, and here's your first precast problem. Use L'Hopital's rule to find the limit x goes to 1 of x to the 8 minus 1 over x cubed minus 1.